All right, I'm going to give you a quick update on my Powerwall on some of the changes I've made. The main thing that I did was finally start to address safety and install some fuses and some other things. I'd always been meaning to, I just hadn't decided on exactly how I was going to lay out my Powerwall, and so the fuses kind of came last, which is probably not the right thing to do. Fuses should probably come first, but you know, the fuses are finally in, and I've also made some other changes. First thing is the second pack is fully operational now, and it has its BMS. So I have two of these 6 kilowatt packs, and they join up on the fuse block and on the breaker block. That's where the two packs parallel up, and then they feed up into the up into the inverter, and the solar feeds back through them. I did change out these two breakers. I had this old Drock breaker in there, and although it would handle the load I was pushing, it used to get quite warm, and actually lately it was kind of having some false starts. When I'd engage it, it kind of wouldn't fully engage, and I'd have to re-engage it a couple times. So I think this thing was slowly burning out. So after much searching around, I came across these Genuine Marine breakers, and these are actually rated for 120 amps at 42 volts. That's the important part, is the 42 volts. This was really only rated for 12 volts. This is rated for 42 volts. So this is 120 amp at 42 volts, and my system pushes 60, 70 amps at most. And I have run my system at full 70 amp load, and this literally doesn't even get warm. So I'm pretty impressed by this Genuine Marine breaker so far, and I think it's going to work good. Then I got a matching one for the solar. Not because I need the 80 amps, just because I like a nice way to break to be able to break the solar and then re-engage the solar as I want. So I use the breaker, and I want to have matching breakers, not mismatched breakers. So so those are the breakers. They are switched to these Genuine Marine 42 volt breakers. So I'm happy with those. Here is my fuse. This is a Bussmann fuse block with a Bussmann AMG 150 amp fuse. This is just in case something goes horribly wrong and you're working on something and you touch two main power wires. That fuse will hopefully kick in and break, because with this many amps, there's potential to for the cables to actually weld themselves to each other instantly, and then you really don't have a way of breaking the arc. So this 150 amp Bussmann fuse, this is an AMG style fuse, and it should cut out, and I think it has a 5,000 amp discharge, or 5,000 amp like breaking capacity, which should be enough amps for this size system of mine. So this can break if something goes horribly wrong. Now, it is installed on the negative. Normally you install fuses on the positive, but this is it's a DC system, so really it doesn't matter whether you break the positive or the negative. And because I had all these breakers and everything running on the positive, it just was more convenient to break it on the negative. But you know, if something goes wrong, it'll still break, because DC systems don't care that much whether you break the positive or the negative. But yeah, besides changing out the breakers, putting in a fuse, I moved the shunt up a little bit to feed the meter over there. Besides that, it's just been the system's been working good. It's starting to get hot, so I'm running my air conditioning, pulling a few kilowatts a day running my air conditioning. But yeah, everything's running good, and I'm pretty happy with the system.